Hello and welcome to Ont in Math. In this edition of Ont in Math, we're going to talk about synthetic division as it relates to the remainder and the factor theorems. Okay, so our objective is to use a factor and a remainder theorem in synthetic division to find the quotient and remainder when dividing polynomials. All right, so we want to talk about terminology used in division. The remainder and factor theorem define roots of a polynomial. Okay, so let's talk about the parts of the division process. So dividend is the value which is being divided. Divisor is the value that's divided into the dividend. And the quotient is the result of the process of division. So dividend 8, divisor 4, 4 divided into 8 leaves us with a quotient of 2. All right, so we can look at it from left to right with the division symbol here, or we can look at it in long division form. So dividend here is the value underneath this bar upside down L. Divisor x minus 2, divide x minus 2 into the dividend, and the result is the quotient 3x plus 8. Okay, so factor theorem, we're going to go back to what we talked about before in synthetic substitution and division. Factor theorem says that for any polynomial, x minus a is a factor if and only if the function p of x, where the value x is equal to a, ends up resulting in a value of 0 through synthetic substitution or division. So x minus a is a factor, a would be the root. The root would end up with a y value of 0. So that's what this is saying. All right, so we're going to apply the factor theorem to this polynomial here, and I'm going to ask, is x minus 1 a factor? Is x minus 2 a factor of this polynomial? So I want you to take a moment here, knowing how to handle the process of synthetic substitution and division, to answer the question. I'm going to pause and I'm going to come back. Okay, so using synthetic substitution or division, again, let's find out if this value is a root or x minus 1 is a factor. So we're going to use 1 as the value here in synthetic division. And we're going to go through the synthetic division process, which we've already explained, so I'm not going to repeat myself. We end up with negative 24 as the last value, which means that x minus 1 is not a factor. So in order for x minus 1 to be a factor here in synthetic division, this result must be equal to 0. Since it is not equal to 0, then x minus 1 is not a factor. All right, so using direct substitution, we can go through the same process. We end up with the same value, negative 24. So either way, we can see that x minus 1 is not a factor of this polynomial. Okay, x minus 2, we can use synthetic or direct substitution here. I'm going to use synthetic, and I end up with 0 as my result, which means that 2 is a root, yes, and x minus 2 is a factor of this polynomial. All right, so now I've got a bunch of problems for you here. I want you to use a factor, what you know about the factor theorem, and then to figure out if in each of these cases this binomial is a factor of each of the respective polynomials. So I give you direct substitution, synthetic substitution, direct substitution. And then number 5, I'm going to leave for you to figure out on your own. I'm going to come back in a moment. Let's resolve all of these. Okay, so the first one I said direct substitution. So the root negative 2, I'm going to substitute in for x, and I'm going to solve, and I end up with negative 11. Negative 11 does not equal 0, so x plus 2 is not a factor. Negative 2 is not a root. Okay, number 2, synthetic substitution. My root is 1 here. 1, I'm going to go through the synthetic substitution process. 0 is a result. So yes, in fact, x minus 1 is a factor, and 1 is a root of this polynomial. Third, x squared minus 3x plus 4. We need to 3x to the 4th, excuse me. We need to reorganize our polynomial. So it would be 3x to the 4th plus 0x to the 3rd plus x squared plus 0x plus 0. So we see negative 3x to the 4th plus 0x cubed plus x squared plus 0x plus 0 leaves us with these values, negative 3, 0, 1, 0, 0. I go through the synthetic division process, and we can see that the result is negative 44. So x plus 2 is not a factor. Negative 2 is not a root. So again, be careful here. We start with the leading term, highest degree exponent. We have a placeholder of 0, 0, where there is no x cubed or x value. So make sure to include these. It's a common error that I see in most homework and tests. And ending result is negative 44. And again, unless it's 0, then we do not have a factor for x plus 2. Okay, number 4, we're going to use direct substitution, synthetic substitution in this case. And we end up, because we don't want to create our bar, right, using synthetic division and write down 100, right, 99, 98, and so on and so forth. We're just going to use direct substitution with a value of, in this case we said we wanted to find out if x minus 1 or x plus 1 were roots. So we have to check both 1 and negative 1. So we check 1 and 1. Yes, 1 is a root. So x minus 1 is a factor, and then negative 1 ends up with it not being a root. So x plus 1 is not a factor. So x minus 1, we're going to check that box here, is a factor. Let's make that a bigger check. Let's put that in red. And x plus 1 is not a factor. Okay, so moving on, last one. It's not too much of a tricky problem, but you're going to rewrite this as x plus 1 squared, because it's a perfect square trinomial. And then we're going to see that the root here is negative 1. Use synthetic division, negative 1 here. We end up with a value of 6. So it ends up not being a factor. X plus 1 is not a factor. X squared plus 2x plus 1 is not a factor. All right, so now we're going to talk about our remainder theorem. The remainder theorem says when a polynomial is divided by x minus a, the remainder is p of a, which means that value that we substitute in for a here into the polynomial. That will end up being our remainder, and I'm going to ask you to place that over the divisor as the remainder. If p of a is equal to 0, then a is a root and there is no remainder. All right, so let's take a look at some problems. Find the quotient and the remainder. I'm going to go through this first one with you. So x cubed minus 2x squared plus 5x plus 1 with the potential factor of x minus 1. The root is 1. Potential root is 1, so I put 1 here. Let me go through my synthetic division process. I end up with a 5 as the last value here. And so that's going to be my remainder. So let's take a look at what we get as the quotient and how it relates to the values that are listed underneath this L here as we go through the process. So this 1 here is a coefficient for the x squared term, and the first term here in our quotient is going to be the value that's has a degree that's 1 less than the highest degree value in our polynomial. It could end up that we have a, well, it can't end up that we have a 0 here. But in this case, we have 1x squared, and then negative x, and then plus 4. So x squared, 1, and then 4. So we go in order, descending order 2, 1, and then 0. So our quotient is x squared minus x plus 4 with a remainder of 5 over x minus 1. And I want you to write it with the divisor here in the denominator. Okay, so I want you to take care of these two questions. We'll come back. Let's take a look at your answers. I'm going to pause here. Okay, so we're finding the quotient for the first one. Negative 1 is a root, negative 1 synthetic division. We end up with 0 as the remainder. Our quotient is x cubed minus 3x squared plus 3x plus 2 with a remainder of 0. Next problem, x minus 1. And so also remember here, we had this placeholder here for the x squared term, which was not listed or not identified in between x cubed and 5x. So 0x squared. We still need to account for the x squared, even though it has no value in the polynomial. Okay, moving on. Number 2, x to the 5th plus x cubed plus x with a factor of x minus 1. Our root, potential root here is 1, 1, and then again, we list the values 1 here for the coefficients. 1 for x to the fourth is 0, for x to the third it's 1, for x squared it's 0, for x it's 1, and then no constant. So again, we go through the synthetic division process. We find the remaining value is 3, and then the corresponding quotient here would be x to the fourth plus x cubed plus 2x squared plus 2x plus 3 with a remainder of 3 over x minus 1. All right, I believe that's it for this edition of Ought in Math. Come and join us next time. We talk about the fundamental theorem of algebra and relate that to our next set of content in polynomials.